Hi everyone. Let's continue our review session. For this video, I'm trying to use the same graph and try to review the Dijkstra's algorithm. So the sample question is this: so given the directed graph with the weights of the edges labeled, explain whether we can apply the Dijkstra's algorithm on it, and starting from the node 0. Okay, so that's the first question, and then if it's doable, and show the updates of the D array and then the sequence of the nodes removed from the queue. And by reading the second part of this problem, and you may feel, okay, this is doable with Dijkstra's algorithm, right? And well, how do you justify that's doable? And you want to bring the lecture notes of the Dijkstra's algorithm and see what is the requirement before we can do the Dijkstra's algorithm. And one thing is we shouldn't have any negative edges. In this part, it is true. Okay, so let me remind you that you know how to trace the algorithm and try to solve the algorithm on a piece of paper or on using any visualization tools. That's cool, but don't forget to check the requirements or the conditions of those algorithms. Okay, so let's move on and do the second part, which is how do we trace this algorithm. So let me bring you guys back to my drawing board. Okay, here. Oh, and by the way, before we start, and if you want to pause the video and take a look on the pseudocode of Dijkstra's algorithm, and go ahead and do that. Okay, so let's start. Well, at the very beginning, and we start from the A, so the cost of going to A will be a 0. And for all the rest of the nodes, we don't know how to go there, so the distance or the cost will all be infinity. Okay? And then, in the queue, we only know the cost of A is a 0, and for all the remaining of the nodes, they are all infinity. So in this priority queue, if we want to do a extract mean, which node are we extracting? The answer should be easy because A is the only node. Well, A is the only 0 node, and that is definitely the minimum. So I'm gonna remove A from this priority queue. So now we are touching the node A. So from the node A at the cost of 0, which node can we go to? We can go from A to B at the cost of 1. We can go from A to D at the cost of 5. We can go from A to I at the cost of 2. Okay, so for the remaining of them, and they are still infinity. So let me update my queue a little bit. So for to B, the cost is 1. To D, the cost is 5. And then to I, the cost is 2. Okay, so after touching the node A, so node A is no longer in the priority queue. And then if we want to do a extract mean, again, which node are we extracting? It should be B, right? So let me cross out B, and then in this round, we are touching the node B. So we know that to get to B, the cost is 1. And from B, where can we go to? We can go from B to H. And then we know the cost of going to B is 1. So going to H, the cost will be a 3. And for all the other nodes, and we don't have anything to update. So let me just write down those numbers. And then we are going to update the cost of H here in our priority queue. So B has already been moved, and then if we are doing another extract mean, what is going to happen? We are going to extract I, right? So I will be removed. So this round we want to touch the node I, and from the I we can go to the E, and going to I the cost is 2. So from I to E another 6. So going to E the cost will be 8 for now. And then for the other nodes, and there's nothing to update, so let me just copy down the values. Okay, and I want to update the cost of the E here in the priority queue. Okay, and the next round, and if we want to extract the mean again, we are going to extract H. And then extract H is the node we are processing for this round. And from H, we can go to C. So the cost of going to H is 3. And 3 plus the cost from H to C, so we can go to C at the cost of 6. Okay, good. Okay, and which, okay, let me update the cost of C. So cost of C is 6. Okay, now if we want to do another extract mean, we are going to take down the D. So next round we are processing the D. Okay, from D, okay, there are two things two ways we can go, D to C. Going to D, the cost is 5, and then from 5 D to C, the cost will be a 9. So we find another possibility to go to C, but the cost is higher here, so I'm not updating this 6. And from the D, which is cost is 5, we can go down to E, the cost is a 6. So for the E, well, I do find another path or another route with less cost, so I want to update here. Okay. So since I have already updated the cost of E, I also want to update here. So let me do that. So now the cost of the E will be another 6. Okay, so well, the next question is there any new node we have discovered? And then the answer is no. So well, here we have to decide how do we want to break the ties. And well, if there, since we have C as a 6, E as another 6. So in this case, and if say we assume the rule is, well, if there is a tie and the tie will be broken using alphabetical order, and then we will visit the C first. Okay, so let's visit the C. And for the C, okay, and then we will discover the F. The cost going to C is 6, and 6 plus is 3. So the cost of going to F will be a 9. So 9 here, and then the cost going to F will be a 9 and nothing else. So I want to copy all the values down. Okay, so after C, and if we want to do extract mean again, we are taking out E. So guess what? For the node E, there's nothing to be done because there's no outgoing edges from E, so there's nothing to be done, and E is crossed out. Now we have F. So extract mean, we are going to do the F, and from the F, we are going to discover G, and the G has a cost of 15. So 15. Oops. I write on the wrong line. It should be here. So G is 15. And then for all the rest of the numbers, and I'm just gonna copy them down. And okay. And then for this line, and since nothing is changed, so I didn't really, I'm just trying to save some time by not writing down any of those values. Okay, so F is crossed out, and then for the G, the cost is 15, right? So for the G, the next round of extract mean, the G is the only value in the queue, so we are gonna process G, and for G, there's nothing to be done again, so we are gonna copy everything down to this line again. Okay, so this is a full tree thing of the Dijkstra's algorithm, and let me bring you back the question. So number one, you have to justify why this graph is doable using Dijkstra's algorithm. And the number two, well, you want to show the updates of the D and then from the sequence of the nodes from the queue, removed from the queue. Okay, so for the updates of the D, and then it's here. So D is a 1D array, and we started the D like this. So we only know how to go to the source. So going to A, the cost will be 0 because A is the source, and then for all the remaining costs, they are all infinity. And then when we touch each of the node, and then the D will be updated. We go all the way down here, and then this line should be the final version of the D. Okay, that's the first part, the updates of the D. And the second part, the sequence of the nodes got removed from the priority queue. How do you get that? They are here. Okay, so going from the A all the way to the G, and this is the sequence that the nodes are removed from the priority queue. So that's it for this video, and I will see you in the next one.